Good morning, students, and welcome to February 1st, and welcome to a snowy math class today. Right now, there's a storm outside, so we'll warm up with some systems of equations, which we will solve using elimination. We started this on Friday. Before we start, I want you to carefully answer to the Do Now prompt about relationship deposits. And today, we will continue solving systems of equations using the elimination method. Our essential question is, what are the 4 steps to solving a system of equations using elimination? For our assignment, we will answer our Do Now in class notebook, watch the video. We have 6 problems to complete. We'll answer the exit ticket and upload our assignment in Teams. And our exit ticket will ask, when I'm solving a system of equations by elimination, I must remember the following regarding the negative sign, and we will review that. Homework tonight, problems 9 through 16. We already did 1 through 8 Friday night. So let's have our camera on. Respond when our name is called at the beginning, middle, and end of the period. Ask for help when needed and smile through the challenges. Just as a reminder, we have a full day of classes on Wednesday, and our map testing begins for the 4th and the 5th. We will test for the first 2 hours, then we'll have 7 short periods for the remainder of the day. So our Do Now says relationship deposits enhance our relationships with others, and we talked about that about a week ago. Now, relationship withdrawals, however, can hurt our relationships. And the question is it possible to remain friends with someone when the withdrawals are greater than the deposits? So can you work through that? Is having a good foundation in your relationship, whether that honesty or trustworthiness, is all of that enough to survive when there are more withdrawals than deposits? And I want you to think about that question and please answer it right here. So we'll get back to our exit ticket in a few minutes. But before we start these problems, I want to go and kind of review systems of equations by solving them by elimination. We had the 4 steps. Step 1, make sure these equations are lined up. X's over Y's, so we can add and subtract appropriately. Step 2 is to add or subtract the equations to eliminate any variable that has a common coefficient, the coefficient being the number in front of the variable. Step 3 will be to solve for the remaining variable. And step 4 is to substitute your answer into either original equation and solve for the other variable. So we have a couple of, these are 2 of your homework problems that I put here. And I just wanted to go over something. So we have y equals negative x plus 1. This is a review. And we have y equals 4x minus 14. So I'm going to remove this so I have a little bit of room to work. Now I'm going to change my color. Now I have 1y in the first equation and 1y in the second equation. So I'm going to subtract. Okay. Now remember, what does subtraction do? When I put a subtraction sign, a negative sign outside there, it simply changes the sign of everything inside here. So what ends up happening is this becomes negative y, negative 4x, and positive 14. So when you subtract the second equation from the first, the y's are eliminated. So we've got 0, and we've got negative x and negative 4x. Well, negative 1, this is an invisible 1, and negative 4 is negative 5x. And 1 plus 14 is a positive 15. So let's move the 5x to the other side of the equation. And we will cancel that. We have 5x equals 15. Divide both sides by 5. And x equals 3. We'll insert the 3 into either of the original equations. This equation is very easy, so y equals negative x plus 1. So negative 3 plus 1 is negative 2. So our ordered pair is 3, negative 2. And similarly, in the next problem, when we subtract this whole equation here, it's going to change all these signs inside. So this will become a positive, and this will be a negative. Use the eraser and write that properly. So, and this will be a negative. So this will cancel. And we end up with 0 equals, so negative 3 plus 8 is 5x. 5 minus 25 is negative 20. So let's move 20 over. Makes it positive. Divide by 5. And our x equals 4. And we'll insert that into this first equation so that it's y equals negative 3 times 4 plus 5. Negative 3 times 4 is negative 12 plus 5, so y equals negative 7. Our ordered pair is 4, negative 7. So that's a little review for you. So let's get into these problems. So for these problems, we start out with 4x plus 9y equals 5, negative 4x plus 7y equals 11, and the 4x and the negative 4x already cancel each other out. So 9 and 7 is 16y equals 16. We divide both sides by 16, and y equals 1. And I'll insert that 1 into y in the first equation and solve for x. 4x plus 9 times 1 equals 5. So that's 4x plus 9 times 1 is 9. I will subtract 9 from each side. 4x equals negative 4. And of course, when I divide both sides by 4, x equals negative 1. So our ordered pair is negative 1, 1. So I did graph this on Desmos. We'll take a quick look at it. I think I did it. I hope I did it. 4x plus 9y. Nope, it doesn't look like I did it. Looks like I started with the 10x, so I didn't do the first one. We'll do the next one on Desmos. Okay, number 6, 10x minus 3y equals 18, negative 2x plus 3y equals 6. So I'm just going to add these two together. Nothing changes, right? So negative 3, positive 3, those cancel. And 10 minus 2 is 8x equals 24. Divide both sides by 8, and x equals 3. I'll insert 3 where x is in the first equation. So I have 10 times 3 minus 3y equals 18. So I'm solving for y. 10 times 3 is 30 minus 3y equals 18. I'll subtract 30 from both sides. And I have negative 3y equals negative 12. I divide both sides by negative 3, and y equals negative 12 divided by negative 3 is 4. My ordered pair is 3, 4. And I know I did graph this one. So here's my 10x minus 3y equals 18, and my negative 2x plus 3y equals 6. And there's my ordered pair, 3, 4. So let's go on to number 7. X minus y equals 10. 3x plus y equals 18. And we've already got those y's all ready to cancel each other out. So negative y plus y cancels those. They become 0. 1x, it's an invisible 1, plus 3x is 4x equals 28. 28. Divide both sides by 4, and x equals 7. Now I will substitute 7 for y in the first equation. I'm sorry, I'll substitute it for x in the first equation. So I'm going to substitute 7 for this x in the first equation. So 7 minus y equals 10. I'm solving for y, so I will subtract 7 from each side. I still have negative y equals 3, and divide both sides by negative 1, and y equals negative 3. My ordered pair is 7, negative 3. And let's take a look at the graph. So x minus y equals 10, 3x plus y equals 18, 7, negative 3, just like we found when we solved the system through elimination. Let's go on to number 8. I have x equals 3y plus 11. 2x minus 3y equals 16. They're not lined up, so we need to really get step 1 in order here. So I'm going to move 3y over by subtracting it from both sides. X minus 3y equals 11. You'll see why in a minute. And then I've got 2x minus 3y equals 16. All I need to do now is simply subtract the second equation from the first equation. So x minus 2x is negative 1x. We make the 1 invisible. Negative 3y minus a negative 3y is like adding 3y, and the y's go away. And 11 minus 16 is negative 5, and we just divide both sides by negative 1 to get rid of the negative sign, and x equals 5. And let's insert 5 for x in the first equation and rewrite that. 5 equals 3y plus 11, and we'll subtract 11 from each side. Negative 6 equals 3y. Divide both sides by 3, and y equals negative 2. My final ordered pair is 5, negative 2. And let's take a look at the graph. So I'll turn these two off, turn these two on, and here we are at 5, negative 2. And that's going on to number 9. 4y equals 2x minus 8. 5x minus 4y equals 20. So I am going to move the 2x to this side by making it negative, and the 4x to this side by making it negative. So now I'll have negative 2x minus, or plus now, 4y. 2x plus equals negative 8. And then the second equation, 5x minus 4y equals 20. So all I did, actually I didn't move 4y. All I needed to do is move 2x over. So I kept 4y because it already is on the left side of the equal sign. Okay, so now what do I need to do to solve this? Let's get a new color. Well, I've already got positive 4y and negative 4y. So that cancels each other out. So I have negative 2x plus 5. That will be 3x equals negative 8 plus 20 is 12. Divide both sides by 3, and x equals 4. Now I will insert 4 for x in the first equation, and I'm just going to go ahead and use the original equation without the negative sign. So I'm show you the original equation. I'm going to substitute this 4 right here for x. So 4y equals 2. Instead of x, I put 4 minus 8. Let's combine like terms. 4y equals 2 times 4 is 8 minus 8. 4y equals 0. And of course, if we divide both sides by 4, y still equals 0. So our ordered pair is 4, 0. And let's take a look at the graph. And this graph indeed, the solution for this graph is right on the x-axis at the point 4, 0. And see how we have a 0 for our y value, which tells us that this equation, or this system of equations, is solved right on the y-axis. Okay, so that both those cross the y-axis at the same place. And that's the last two problems. 3x minus 4y equals negative 10. And 3x minus 4y equals negative 13. Be careful with this. This is a little bit tricky. If we try to subtract this, so that what we can have is subtracting a negative makes that positive. So we cancel out the 4y's, but then we also, because we have negative 3x and positive 3x, we end up canceling out the x's as well. So we have 0 equals, and negative 10, negative times a negative is a positive, negative 10 plus 13, 0 equals 3. Okay, well, that's not true. So what we have is a no solution. So I think I graphed these as well. Let's take a look at them. So 3x minus 4y is negative 10. 3x minus 4y is negative 13. And of course, we have parallel lines. There's no solution. And the final problem of the day, I'm going to rewrite this second one. I'm going to take this 2x and I'm going to put it over here, negative 2x. Okay, so the first equation, 2x plus y equals negative 10. The second equation, negative 2x minus y equals 10. Now look carefully what happens. 2x minus 2x cancels. That's 0. 1y minus 1y cancels. That's 0. That whole side is 0. On the right side, negative 10 plus 10 also equals 0. Well, we have something equals something, and they're both the same. What we have is an infinite number of solutions. So let's take a look at the lines. Here they are, and what you see is every point that is part of the line of the first equation is part of the line of the second equation. Those two are absolutely one and the same line. Every point that is part of 2x plus y equals negative 10 is a part of negative y equals 2x plus 10. If you were to put them in slope-intercept form, they would both have the same exact equation. So let's go back to our paper and let's review and let's go through our exit ticket. So when solving a system of equations by elimination, I must remember the following regarding the negative sign. When I subtract a negative number, when I'm subtracting a negative, it becomes positive. And just think back to your integer work when you first learned about integers. So if you have negative 1 minus 5, that equals negative 6. Okay, just like 1 plus 5 equals positive 6. But if you have negative 1 minus a negative 5, okay, that's negative 1 plus 5, which would be 4. And that's the same thing that happens when we did these in this example here, and the same thing that happened in this example here. You see it right there. So that's the trick to remember. When you subtract a negative, it becomes positive. Almost think of it as multiplying a negative times a negative, because you're multiplying a negative times a quantity within parentheses. So we've only done a few problems today, but I really want to make sure that you understand this, and I want to make sure you have just the right amount of practice. Do the remainder of the homework problems. Keep practicing. Write to me if you have any questions. And as always, you're working hard, so with practice, you'll be great.